Hi everyone, and welcome back to Maths and Physics with Mr. Simons. Now we're looking at the third variation of identities, fractions. Now I know generally when you'll hear fractions you'll switch off, but if you take the time to listen and follow very carefully, I promise I'm going to try to make it as easy as possible for you to show you that you can actually do this. So stay with me. So prove the following. 1 over sine x minus sine x must equal cos x over tan x. Number 2, tan squared x plus 1 equal 1 over cos squared x. Tan x plus 1 over tan x equal 1 over sin x cos x. And number 4, tan squared x minus sin squared x equals sin squared x times tan squared x. So again, can attempt to do all of them and then look at the solution. So you can pause the video here, attempt them. As I say, from here onwards, I'm solving. So very important, when you see tan, generally in problems, because tan is sine over cos, this becomes a fraction problem. Same there, sine over cos, that becomes a fraction problem. There, tan sine over cos become a fraction problem. So this I'm just explaining as a guidance. So there, because it has minus, plus, plus, minus, to add one fraction to the other fraction, we must always ensure that they have the same denominator. So that's in theory what you're going to be testing here. So let's go through it. So number 1, we have 1 over sin x minus sin x equal cos x over tan x. So there, 1 over sin x, my denominator is sin x. So sin x there is the same as saying sin x over 1. But to add this fraction to that fraction, you see they have sin x and they have 1. So that 1 must also read sin x. So therefore, I'm going to multiply by the value 1 by saying sin x over sin x. Remember, anything divided by itself equal 1. So there, by me multiplying by sin x over sin x, I'm not changing the fraction. So sin x times sin x becomes sin squared x. And 1 times sin x becomes sin x. So now you see the denominators are the same. I have sin x and sin x. So from here, 1 minus sin squared x on top over sin x. But remember, 1 minus sin squared x equal cos squared x according to the square identity. So therefore that becomes cos squared x over sin x. Right, I can expand that and write it as cos x times cos x over sin x. But you should know that cos x over sin x becomes 1 over tan x. So although they say we mustn't teach cot from grade 11 onwards, basically sin x over cos x is tan x. So when I flip it around, it becomes 1 over tan x, or technically cot x. So there, cos x, and then cos x over sin x, that 2 becomes 1 over tan x. So my answer becomes cos x over tan x, which then equals my right hand side. Alright, so hope we're still together there. Please like and subscribe. Number 2, we have tan squared x plus 1 equal 1 over cos squared x. So we should know tan squared x, the quotient identity of it is sin squared x over cos squared x. Again, to add two fractions, I assume you get it into your head. Denominators must be the same. So 1, now write as cos squared x divided by cos squared x. Remember, anything divided by itself is 1. But now I'm showing that the denominators are the same so that I can add the numerators. So there I have cos squared x, and now I have cos squared x. So I can say sin squared x plus cos squared x for the top. But according to the square identity, sin squared x plus cos squared x equal 1. That gives me 1 over cos squared x, which then equals my right hand side. So I've made this equal to that. Therefore, I've proven the identity. Right, number 3. So we have tan x plus 1 over tan x equal 1 over sin x cos x. So again, I must make the left hand side equal the right hand side. So tan x will be written as sin x over cos x. 1 over tan x is the same as saying 1 divided by sin x over cos x. Alright, so I have sin x over cos x plus 1 times. If I change division to multiplication, I invert or flip the fraction around at the bottom. So therefore it becomes cos x over sin x. So in short, now I have sin x over cos x plus cos x over sin x. Now to add this fraction to that fraction, the denominators must be the same. Right? Because I only have two fractions, I'm going to multiply the denominator. So I say sin x times cos x gives me sin x times cos x, and then we cross multiply. So sin x times sin x, cos x times cos x. Right? It's just a shorter process. Instead of going to write times sin x over sin x here and there times cos x over cos x. Right, so from there sin x times sin x and then cos x times cos x. That gives me sin squared x plus cos squared x over sin x times cos x. And sin squared plus cos squared then becomes 1. So equals 1 over sin x times cos x, which then equals my right hand side. So that identity proven. Let's look at the fourth problem. And I promise if I have time, I'll do some more fractions for you. As I will say, I believe practice makes perfect. The more you do it, the easier it becomes. So for number 4, we have tan squared x minus sin squared x equals sin squared x times tan squared x. So tan squared x can be written as sin squared x over cos x minus sin squared x over 1. Again, there's a plus or minus sign, there's a fraction, so to add a fraction to another fraction, we have to ensure that the denominators are the same. So here I multiply by cos squared x over cos squared x because I want cos squared x at the bottom. So I have sin squared x over cos squared x minus sin squared x times cos squared x, and 1 times cos squared x becomes cos squared x at the bottom. And there it becomes now sin squared x minus sin squared x cos squared x, because denominators are the same, over cos squared x. On top, you can see between the minus sign, I have sin squared and sin squared. So therefore I can take that out as a common factor. So sin squared divided by sin squared gives me 1. Sin squared divided by sin squared gives me 1, but 1 times cos squared x stays cos squared x over cos squared x. 1 minus cos squared can be written as sin squared x, right? And now we have sin squared x, but sin squared x over cos squared x simply becomes tan squared x. So that now equals my right hand side. Hope you enjoyed the lesson. I hope it helps you a lot. Continue practicing. Don't give up on your dreams. With hard work, success will come. Work hard now so you don't work hard later on in life. I wish you nothing but the best. Please share, like, subscribe. God bless. Bye.